Hey, some of you guys might be watching this video because you're having issues with the standing wave simulation, so I'm going to walk you through this lab. So we talked about standing waves, and you'll see that if you have one harmonic, it'll look like this. Two, it will have two, and then three will look like this. Four and five, and you can just see we just count our antinodes here, and that's how what harmonic you're working with. So anyways, to do this lab, first this is what the simulation was. We're going to create, set up the ruler right here, and then we're just going to start it. And you can see we have a three harmonic standing wave. And I am going to put the ruler right here. Now, actually, to measure the wavelength, you actually want to put it where you see two of these waves. That's one wavelength. Two of these antinodes. So here you have it at 12. And so if you go back here, and you can see this is why I put a 12 here. And this is in centimeters. So to convert to meters, it'd be 0.12. And then the frequency at which this is happening is at 75 hertz. And then all we do is multiply the two numbers to get a number. All right. So let's start playing around with this and seeing what we get. So if I dialed it lower and I go to 50, now I can see that I have two antinodes. So it's a harmonic right here of 2, and so each one of these antinodes looks like it's 9. So if I was to measure one full wavelength, it would be at 18 for 2. So I would just put right here 18. I would put 0.18. And then for the hertz, it's at 50 hertz. So I'm just going to complete this part. I assume you will have a calculator, and you can just multiply these numbers to see what frequency times wavelength is equal. And then if we were to dial this so that we only see one harmonic, lo and behold, we'll see a pattern here. That would be 25. Now, the wavelength of this is 18, but then remember, to measure the wavelength, we want to measure two antinodes. So this would be double of this. That would be 36. So double of 18 is 36. So I'm going to put 0.36, and you should notice that as the harmonics go down, the wavelength goes up. And what frequency was it at? I believe it was at 25 hertz. All right, and we're going to start seeing a pattern here. Now let's go to 4. Now to get to 4, remember we started at 75 and we saw that we had 3. So I'm going to just dial this up. And if I dial it up to 100, now I see that I have 4 antinodes here. And to measure the wavelength, I'm going to put it right here. And that is the measurement of one wavelength, which is now 9. So as you can see, as the harmonic goes up, the wavelength goes down, so 0.09 meters. And this was at a 100 hertz, okay? And then we can see this pattern, 25, 50, 75, 100. I wonder what the next one's going to be. So we will go to 125. And as you can see, I will now need to move this down. The wavelength has dropped, right? And now I'm at 7.25. 7.2. So that would be the new wavelength. So we could put 0.72. Okay, and this would be at 125 hertz. Okay, and then as we keep moving it up, okay, the next one probably would be 150. And then at 150, lo and behold, we'll see that it's at 6 centimeters. So I'm going to put 0.06 centimeters at 150 hertz. And then the final one, what do you think is the next pattern here? You should probably see this pattern, and We're going to dial it up to 175. And here now we have, should be at 1, 2, 3, 4, 5, 6, 7, the harmonics of this. So we see 7 antinodes. And we're going to put this right there. Okay. And looks like it's 5.2 about. So we can go 0.052. And this was at 175. All right. And you just need to multiply out. You'll have your data, and then you can answer these questions. I hope this helps.